good evening, students. Today we will start a group 16 elements of P block. So in the 16 element, sulfur, selenium, tellurium and polonium is coming in this group. Okay, this group has been taken from the Greek word said to be as oxides, sulfides. We can say Greek word. The name is derived from the Greek word for brass and indicated the association of sulfur and conjugance with copper. Occurrence, how it is formed like carbon dioxide is react with the water in the presence of chlorophyll and the sunlight to form glucose and oxygen. Sulfur is the 16th most abundant element. It is the most important and abundant element is there. Okay, the common sulfide mineral are galena, PVS, CaSO4.2H2O, some salts and etc. Characteristics first of electronic configuration. In this one we are using at last NS2NP4. Okay, next we will tell about the atomic and the physical properties. The atomic and the ionic radii of the element of its group are smaller than those of corresponding element group 15. The atomic and the ionic radii of elements of group 16 as accepted increase on the putting down the group. Okay, they will increase when they are going down the group. Ionization enthalpy is also depends upon the nitrogen family. As we will go down the group from oxygen to polonium, the ionization enthalpy is decrease. Okay, melting in the boiling point increase with increase in the atomic number as we go downside in the group. Okay, so it is better the properties are given for us. These properties you have to write down in the copy. Ionization enthalpy, melting in the boiling point, atomic and physical property, electronic configuration. Electronic configuration, for an example, we are using here oxygen. So at last it is coming as 2s2 2p4. Like sulfur, it is coming as 3s2 3p4. As we are telling about the ionization enthalpy, in this one also nitrogen 7 is there. It is said to be the 1s2 2s2 2p 3 will convert into x, y and z. Okay, melting point and boiling point is also increased with increase in the atomic number as we go down in the group. After this we are going to tell you about the electronegativity. Electronegativity is the oxygen is the second most electronegative element, being with fluorine. Electronegativity decrease when we are going down the group. Metallic and the non-metallic, 4 elements are there: oxygen, sulfur, selenium and tellurium are non-metals. They are stronger. In the other words, last element is marked metallic. Okay, electron gain enthalpy, the value decrease down the group. Sulfur to polonium means they will go down. When they are down the group, they will go increase. Catenation is a tendency of an atom to form bonds with identical atoms, means it form a bond as covalent bond and other bonds. Next is elemental state. Elemental state come as oxygen exists as a diatomic, means O2 atomic. So it form as O double bond O. The intermolecular force is there. One double force of attraction will takes place. Allotropy formation takes place in oxygen, sulfur, selenium, hexagonal, tellurium and polonium. Oxidation state is also present, that is NS2 and NP4 configuration. Okay, so this is the things, allotropy and elemental states. These things write down in the copy. After these things, it is came as a negative oxidation state also. Oxidation state is very high value, okay, of electronegativity. It tends to achieve noble gas configuration. There are few exceptions. Exceptional things are also be there, in which oxygen is not -2. For example, the oxidation state of oxygen is OF2 is +2. This is the exceptional cases. Fine. OF2 is +2, O2F2 is +1, H2O2 is -1, O2 or O3 is 0. So different valencies are there. They are coming in the exceptional cases. After the oxidation state, there is a positive oxidation state also. Positive oxidation state is like OF2 and O2F2 is the exceptional case, and other oxygen element as +2, +4, +6 is there in D block orbitals. After this, you can see the table. In oxygen, it is putting as 2s and 2p. So 8 electrons is coming in oxygen. So first we will fill the 2s, then we will fill the p1. So you can see one is clockwise and second is anti-clockwise. The electron will not go in d orbital. Let's see the sulfur. Sulfur next, in this also it will not go in the d orbital, but sulfur atom in the first excited state it will go in the d orbital. One electron will go there. Sulfur atom is second excitation state, means two electrons will go in the d block elements. Chemical properties is also be there. Reactivity decrease here as oxygen is decreased with sulfur, then selenium and tellurium. Okay. P block elements present in the second period oxygen shows anomalous behavior due to small size, high electronegativity and a high ionization enthalpy with the absence of D block valence shell. Okay. So in this one, due to the absence of D shells in oxygen, covalence is limited to 4 in practice, rarely exceeds 2. In case of other elements, the valence shell can be explained using vacant d orbitals. Okay, here we are using a vacant d orbital. Next, in a chemical properties, reactivity with hydrogen takes place. Okay, volatility is there, explanation is there, acidic character. In a acidic character, H2 is greater than H2S, H2S is greater than H2SC, H2SC is greater than H2TE. In this one, they are saying that which one is more acidic, that in this way the question will come. Reactivity with hydrogen, all the elements of group 16 form hydrides of the type H2E. Example is H2O, H2S, H2SE, H2TE, H2PO, like this. Okay, you can see the diagrams also. Structure of water formation takes place with a tetrahedral. So its geometry is coming as 104.5 degree. Find the graph. Plotting of boiling point graph is also possible there. Hydrides of group 16 can say that acidic strength is increased with thermal stability decrease and with reducing character is increase. Okay. Volatility means hydrides are volatile. Volatility increase from water to H2S and then decrease. From water till H2S it will increase and then after that it will decrease. The high boiling point, therefore low volatility of water, is due to the association of water molecules is present. Fine. Next, the third point we can say is a thermal stability. Thermal stability of the hydrides decrease from H2O to H2E. Means it goes on decreasing. Means H2O decrease with H2S, H2S is decreased with H2SE, H2SE is decreased with H2TE. Explanation will be taken place as on going down the group, the size of the central atom increase and therefore tendency to form stable covalent bond. It form a covalent bond with the hydrogen decrease. Fine. In this one, reducing character, all the hydrides except water are reducing agents. The reducing power of these hydrides increase from H2O to H2TE. The H2O decrease, going on decreasing till H2TE. Okay. This is due to the decrease in the thermal stability of the hydride, because when the decrease in thermal stability, then there is decrease from H2O to H2E. One diagram is there. Structure of hydrogen peroxide. The angle formation 97 degree takes place. Other hydrides will also be taken place like hydrogen disulfide, hydrogen trisulfide, hydrogen pentasulfide. Reactivity with oxygen is also taking place in group 16, such as EO2, EO3. In place of E, we are using here sulfur also. Okay, SE, or PO. Okay. After this, you have to write down these things in your copy. Now, oxides may takes place as monooxides, dioxides, trioxides. Its properties also will be there. So, oxides of sulfur are more stable than the oxides of other elements. Oxides of sulfur is more stable. First of all, the monooxide. All elements except selenium form monooxides. Except selenium we have taken out. Other monooxide means a single one. They both are form monooxides. Let's take up one example. Example here is SO2 plus S in the presence of 475 degree Kelvin to form 2SO. Okay, it is also prepared by the action of silver on thionyl chloride. SoCl2 plus 2Ag give SO2AgCl. In a dioxide means two members will take place. E plus O2 gives EO2. S8 plus 8O2 gives 8SO2. It form a dioxide means p pi pi bonding takes place. P pi pi double bond will takes place. Angular structure will takes place. Okay, so this is a structure you can see in SO. After this they form a geometry. You can see in the ground state it form a 2 electrons in 3s, 3p, 4 electrons, but in D no electron. When the hybridization is taking place, the electron which is on the 3p, that electron will go on the D block orbital. Okay, so one electron will come in a D block also. See the structure of figure 23 also. Resonance portion will taken place here. When the resonance portion will taken place, the bond will go the left. First of all, the lone pair shift from one side to another, transferring of the lone pair. After the transferring of the lone pair, then it form a double bond. Okay, after this we can say what are the properties of it. The dioxide differ one another in their reactions with water. Okay, so what will happen here? SO2 dissolve giving H2SO3, which exists only in the solution and cannot be isolated. It is SO2 plus H2O gives H2SO3. H2SO3 when boiled gives again H2O and SO2, means reversible reaction is there. In a trioxide, we can say all the elements of this group, trioxides of the formula EO3. It will come EO3, or for EO3 we are writing as SO3. So example here, atmospheric pressure is also be used and the temperature here is used. 2SO2 plus O2 gives 2SO3 in the presence of platinum V2O5 with 2 atmospheric pressure. H2SO4 again gives SO3 in the absence reducing of water in the presence of the heat and P4O10. Okay, SO3 has a trigonal planar structure in the gaseous state in which S atom is sp2 hybridized. Okay, the 3 sp2 hybrid orbitals of S overlap with p orbitals. Next you can see the diagram in the hybridization state, like 3s 2 electrons is there and 3p 4 are there, but in 3d nothing is there. But as the hybridization takes place, we can see 1 electron will come in 3s and 4 electron will come in 3p. The rest 2 electron which is left, they will come in 3d. So what is the geometry formation takes place? The geometry formation takes place is sp2. Okay, or we can say as sp3d2. Okay, because in the d 2 electrons will takes place. The diagram figure SO3 is there. So d pi electrons are there. Resonance portion will be there of this one. SO3 diagram is also there. As before I have tell you about the resonance. So these things you have to write down in your copy. After this, SeO3 is prepared by the direct oxidation of Se or SeO2. It is a white hygroscopic solid having melting point 118 degrees Celsius. It exists as monomer in the vapor state and a cyclic tetramer. Okay. Next we can say there is a table 13. This table you have to write down in copy about the oxidation of sulfur. It says as S2O has plus 1, then plus 2, plus 3, plus 2, plus 3, plus 7, plus 8. So according to the oxide, you can write down the oxidation number. Reactivity halogens. Halogens may take place. Halogens you know, chlorine, fluorine, bromine, iodine. So fluorine is greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine. Okay, table 14 also I have to write down in copy. After that, monohalides will take place. In a monohalide, 2Se2Cl2 gives SeCl4 plus 3Se. After this, dihalides. Dihalide portions are there. In a dihalide portion, 2 halides will take place like SCl2. It form an angular structure with the angle of 103. Tetrahalide means 4 are there like SEF4, SF4, TEF4 like this. Its structure formation is also be there. After this, pentahalides 5 will be there. Okay, hexa means 6 are there. SF4 plus 2H2O and gives 4HF plus SO2. Okay, after this SF6 plus H2O gives no reactions. Why it is so? Because they will not react with each other. As structure of SF6, it form a 1, 2, 3, 4, 5, 6 electrons, 6 bonds it form. TeF6 plus 6H2O gives S6TeO6 plus 6HF. Okay. So analogous behavior of oxygen will also take place. These things you have to write down in your copy, students. So here we highlights are completed. Di, tri, tetra, penta, hexa, hepta. This you all know. And we have completed the resonance structures also. In a resonance structure, the transferring of electrons will take place. Beta, these all things you have to write down in your copy. Okay. So don't waste the time and write down in a copy where you got the time. Okay. And thank you, students. So these things you can write down in your copy. After that we will start dioxygen preparation. Dioxygen is prepared by thermal decomposition of oxygen rich compounds such as KClO3. What is dioxygen? Dioxygen is an allotrope with oxygen represented by a chemical formula O2. It is generally known as oxygen. It is also called dioxygen, molecular oxygen or oxygen gas. Laboratory preparation of it catalytic property, it form a 2KClO3 to give 2KCl plus 3O2. This reaction occurs on heating in the presence of MnO2 at 420 Kelvin. Second reaction we are using with the thermal decomposition of metal oxide with relatively low electrode potential in the electrochemical series. So in this one, what the thing may takes place? The thing may takes place as 2HgO plus 2Hg plus O2. It gives 2PvO2 gives 2PvO plus O2. Now next is salt rich in oxygen like nitrates and permanganate produces dioxygen when decomposed thermally. So its reaction formation takes place as 2KNO3 to gives 2KNO2 plus O2. 2KMNO4 to form K2MNO4 plus MnO2 plus O2. 2NaNO3 gives 2NaNO2 plus O2. Next reactions we are doing with the decomposition of hydrogen peroxide also produces oxygen and to increase the rate of decomposition. So here we can take as 2H2O2 in the aqueous formation to gives 2H2O plus oxygen. As we are using for the industrial preparation of the oxygen, so we can say first of all the fractional distillation of liquefied air with nitrogen distilling as a vapor while oxygen is left as a liquid air. Liquid air is a mixture of liquid nitrogen and liquid oxygen. Nitrogen is more volatile. Why it is a more volatile? Because it's having a lower boiling point. It boils up first, leaving behind some residue over it and form a pure oxygen. After this, another method include passing of clean dry air through one bed of a pair of zeolite molecular sieves which absorbs the nitrogen gas. Means is this, in this one the nitrogen gas is absorbing and delivers the gas which is 90% to 93%. After this, the properties of dioxygen may takes place. It is generally neutral towards the litmus, means neither the litmus paper will become blue, neither will become green. Second, it is an odorless, colorless and tasteless gas which liquefies at 90 Kelvin and freezes 55 Kelvin. Second, it is a heavier than air. Okay, what is heavier? Dioxygen is heavier than the air with a density of 1.429 gram per liter. It is slightly soluble in water, which is just sufficient to support aquatic life. Fourth is the melting point of oxygen is around 54.36 Kelvin and the boiling point is around 90.188 Kelvin. Oxygen exists in all the three forms such as solid, liquids and gases depending upon the temperature and the pressure. Fine. Chemical properties start. In a chemical properties, first of all it forms 4Na plus O2 gives 2Na2O. C plus O2 gives CO2. It is a paramagnetic in nature. It forms oxygen is a good oxidant and hence support combustion such as fuel plus oxygen. In the presence of the oxygen, it forms CO2 plus H2O. Example, methane is react with the oxygen to form carbon dioxide and the water. Now, uses of dioxygen. It is a vital for the respiration process. It is used in oxygen cylinders which are used in the hospitals. It is used as a rocket fuel in liquid form. It is used in the production of nitric acid. Oxygen gas combines with acetylene gas and produces an oxyacetylene flame used for cutting and other uses. So these all things write down in your copy. Students, have a nice night.